Okay. Oh, I literally was. It's the alternate.
I'm just gonna start recording. Last time I forgot to start.
Okay. Yeah. Oh, I asked. Yeah, if I do, we changed that. What, you don't use an Android?
Apple all the way. It's not edible. Never buy it.
How do I change? This is Samsung. All these like. Well, it's like these are like just like it's for like
What is the status thing?
yeah, it's like your stat. I just met those people like once for hours. Like follow each other. Like it's like
Unfollow them. Hopefully they don't notice. So that you like it's like your ratio.
am I like what I do?
It's like
Wait, what's my I think you do that kind of like weird.
it's like a status. And I was like, yeah, dude, I'm just so interested. You just follow me, and I don't even.
No one does that though. No one just follows people. Everyone knows people who do that like weird. They're like that follows people.
Everyone follows me. And all of these people.
This is Cristiano Ronaldo. I didn't do the homework. I saw it. Is there homework for this? This is like ACM Island. ACM Island with new people. Yeah.
Yeah.
It was just me like talking to Jordan.
That's great, just you.
No, it's me and like these like 5 other people, and then everyone else just like leaves like ACM Island.
Really? Why?
I don't know. The people like aren't like paying attention, so I'm just like asking for a new question.
Is that for like which track?
Advanced.
Oh, okay. I don't understand. It's probably just going like on spring time.
Oh. They're kind of like we could go to the reading sessions every week. I came to like I was the only freshman at the last one, and then like I didn't understand anything. I finished my resume by the way.
Oh,
Like so
4.0. Holy shit.
I took stats 10. I took stats 10 C/slash level 4.0.
Single variable. Oh, yeah. This is very quick.
I'm single variable.
This is I would just combine this. Okay. SQL quantity modeling nice. Pandas. Dude, that's just all that means is you're gonna get like a year.
I don't even do anything. That's what my dad was telling me. He told me that.
No.
Okay, sorry. Yeah, I think everything's set up. So, hey everyone, thank you all for showing up. I know it's kind of late in the quarter, and attendance has dropped a little bit, but yeah, we're really happy that you guys are all here. Yeah, yeah. So today we're going to be covering distributed processes. Cool. Yes, that's what I'm saying.
All right, so computers, processes, and threads. So, like, what is a computer? All it is a piece of hardware that performs computations. If you think of like a calculator, it just performs a set of like plus, minus, multiply, divide. And then if you have enough of those, you get this thing on a computer. And so there's some software on your computer, right? It's usually an operating system. And the job of an operating system is to bridge the gap from your software to your hardware. Right. So how does your computer standards change over time? Anyone have any ideas? So, NVIDIA, new GPU every year. Intel new CPU. So how do you think how do computers change? Drivers. Okay. So like we have different constantly evolving standards. And so we used to have like 16-bit operating systems, and then turned to 32. Now it's 64 as a standard. And then this could cause a lot of issues because the interfaces between your software and hardware can change a lot. And so, yeah, the operating system job is able to bridge this gap. And so a key issue is portability and profitability. So companies, when they make software, they don't want to keep changing, right? They want a set standard that's very easy to use, and does it change no matter what the underlying hardware becomes. Or and so how exactly do we avoid this cost of porting our code to another new platform? We use virtualization. And so basically, if we think of virtualization, think of what your operating system does. We don't build our software for our underlying server. All we do is build it for the operating system, and then the operating system handles the hardware interactions. And then if we extend this idea, we can have what's called a hypervisor, which is basically it's a virtualized environment. And so instead of having only one operating system, we can have multiple different operating systems. So for example, think of this. This could be like Windows. This could be like Linux. This could be like another like Mac or something, Mac OS, and they can all be running on the same single machine with our hypervisor. And so there's different levels of virtualization. So we have ISAs, system calls, and we have libraries, and then just like the application layer. So the ISA is the instruction set architecture, and so think this is like basically your hardware interface, right? So when you have like a CPU, Intel and ARM CPUs have different instruction sets, right? So Intel is like the sys complex instruction set. ARM chips are RISC, and they both have their different standards for how to write machine code for those platforms. So that's what an ISA is. And system calls are basically the operating system providing a library for the end developer, and then it pretty much just wraps up this functionality to interact with the hardware. And then we have a library, which is basically just some software compiled for a particular operating system, and then the software is just whatever you write. And so we can match them here. And so from the application layer to the library, we interact with it using library functions. Our library will typically, it will typically handle all the interactions with the operating system calls. And then our operating system interacts with our hardware using privileged system call instructions. In order to provide in order to provide like a more concrete example, have any of you guys used OpenGL before? No. Yeah. So OpenGL is basically a graphics library, and so you can have many different underlying GPUs. Like you can do like an NVIDIA GPU or like Intel shittier GPU. But yeah, you OpenGL pretty much just handles the interaction with the hardware device for you, right? It basically just creates a system call, and then your operating system then handles that. And so you as a developer only need to know how to use OpenGL. You don't have to worry about any of this other underlying stuff. Okay. Yeah, who can tell me the difference between a process and a thread? Look at the picture. You're the new one.
Multiple threads in the process.
Yes, exactly.
Okay.
So yeah, a thread is basically just a control flow, right? So each thread is going to have a register, counter, and a stack. And so what this allows you to do is that you can basically run like multiple different functions at the same time. You can like kind of switch off between each function. Now that may sound similar to like a process, because you can also have a process running the same function as well. So like where exactly is the difference? So here we have a diagram of a multi-threaded program. And so we see that the code is shared, but each thread has its own like program counter, identifying where exactly in the code it is and what local data it has accessible to the thread. However, for multi-processing, all of this is just a single process, and just think of like having multiple of these all occurring at once. So we have like a separate code area, and all the data is much more separate compared to multi-threading. So since we have to copy all of this each time we want to spawn a new process, the overhead is going to be much higher than simply spawning a thread. Okay, and here's an example. So here, this is like a single thread where we're basically adding 1,000 integers to the sum. And then we can also think of it as you're splitting up the computation space and just running all these three loops at the same time and then aggregating the results. And so this is kind of similar to the idea of like MapReduce. And you're basically just splitting up your inputs, sending them over, and then you're aggregating the results into a single number.
Cool, yeah, so any questions on that, on computers, processes, threads, on a single machine? Cool, yeah, so yeah, we're gonna talk a little about how we kind of virtualize machines in a distributed system. So yeah, think back if you were here for our first kind of GM, and just as a quick refresher, we essentially had a kind of simple client server distributed system where our client was essentially just a small website where it would display two numbers, and then those two numbers would be added. And to do the actual addition, we were kind of making an RPC call to our server node here that would actually handle the computation and kind of patterns of that. So yeah, so what we can see, we're going to kind of classify that in a second, but we're going to go through a couple different examples of how folks generally choose to virtualize in a distributed system. So the first approach here, can you minimize the first approach here is taking infrastructure as a service. So with this approach, essentially, we kind of abstract away all of the hardware, like networking requirements and everything, and only let the customers, people that are kind of designing software, have control of the operating system, any kind of direct storage that they need, and then the code that they're actually running. So kind of what this reads is something akin to what you're doing on your own computer for the project, where you're kind of choosing an operating system, which in our case we chose it for Linux, and then you're kind of running your own Python code on it, and you can kind of run a database on it if you want, kind of configure security as necessary. So yeah, basically the keys here are that you do have control over the OS that you choose, but it's virtual, so it's more than likely using that hypervisor that Daniel talked about. And you have quite a bit of control, but there are a couple things that you're giving up. Okay, so in contrast with infrastructure as a service, there's a notion of having a platform as a service. So this is something where essentially you would have some code that you want to run, but you don't really care what operating system it's run on, and you don't really maybe you'll configure some security settings, but you don't have kind of full control of like the actual configuration files for security, and the full freedom to kind of configure it as you'd like. So why might we want to choose to run some code with something like this as opposed to infrastructure as a service where we have more control? Yeah, so the trick with this is that we're choosing to give up control, but we're also abstracting things further away, meaning that we can kind of assume that they will be handled properly, right? For example, configuring which operating system you want to use might be a bit tricky, but if you don't care, right, if you're just running some Python code, then there's no real reason for you to have that ability to choose an operating system if you don't need to. So something like this is akin to, I don't know, have any of you guys heard about AWS Lambda service? Like if you've ever heard about like serverless computing, essentially what they're doing is there is a server obviously running some code, but you as a user don't really care about the configuration of that server. You just have some code that you want to run. So you're saying, hey, this is my code, run it on whatever hardware you want. Hence the kind of serverless aspect, right? You're not configuring the server. So that's kind of a great use case of a platform as a service model for virtualization. Okay, yeah, and another example here that I have is Heroku. It was a little bit more popular back in the day because I believe it was free, and now it's been charged. So, but the idea here is that you're able to kind of write code and then kind of build your code and create like an accessible endpoint for like, all users on the internet. But you don't actually have to go and configure the server, like the actual kind of operating system, like the actual nodes that are being running on, anything like that. They do have some kind of configuration features, but generally they're optional, and they are defaults all set for you. Cool. And then the last one here is we have software as a service. Can you press it one more time? Yeah. So essentially, this is where they're just giving you a software directly, and you can integrate that into your workflow without having to do any coding at all. So yeah, some like kind of prominent examples would be like Slack or Google Drive. They have APIs available for kind of interacting with these software services, right? And they also have like user interfaces. So generally, if you're using Google Drive, you probably just go and click through, right? So in your browser, or Slack, you may kind of just scroll through and then type your message. But in the way that we're kind of talking about these, we're thinking more along the lines of something where maybe you have like a workflow and you need to send notifications if something fails. You can kind of directly integrate that into like Slack kind of API, and send notifications to Slack such that you would be notified if something's going wrong, without having to actually go and write any code on Slack's application. Right? It's directly accessible as a software service that you can kind of integrate into your own workflow as you desire. Okay, so yeah, here we kind of have the four main approaches all laid out. So the key thing to realize here is that on the far left, we have the kind of a traditional approach where everything is like on site. If you remember way back in the first workshop and GM, we talked about kind of having your own hardware and running everything on it. And that system, although it has a couple advantages, it has a lot of disadvantages. Namely, you have to pay a lot of money up front, but you have to kind of pay to maintain the hardware. If it fails, you have to kind of pay to repair it. But with these three on the right, these are kind of more akin to something you'd see in a distributed system where the hardware is abstracted away and kind of making use of the techniques that Daniel talked about. Your generally the cloud service provider would take care of maintaining all these bottom 5 layers. And depending on which of these 3 approaches you choose, you would have different degrees of control, and you have different degrees of kind of expecting things to run smoothly. Okay, any questions on those 3 virtualization approaches for distributed system?
All right, so yeah, we all know about the, like the client and server separation to have our distributed system. And so last time we talked about having layered object resource and event-based virtualization for our architectures. And so the purpose of this is to make clients transparent, to provide transparency for the clients and hide the fact that the server is remote. Yeah, and then this is a quick review. We have to synchronize our application, and then all application logic is going to be on a server through an RPC. All right, so how exactly do we organize the logic in our server? Well, one way we can do this iteratively, right? So as we have a request, we then send a response, and then only after we finish sending the response, we can then accept and process another request. However, this is going to be pretty slow. It's going to like very limit our workflow or like our workload a lot. So another thing we can do is just like we accept the request, we acknowledge it using just like we send a message saying like, yeah, we got your request, and we just keep doing that. And then once the result is finally done, then we send it. So this is called concurrent process, and it's going to usually be done asynchronously. And so there's 3 general ways to model a server. So the first way is multi-threading. And so this is basically where you have a bunch of threads, and you typically switch off between each thread when you have like an input-output operation. So like, for example, you're reading from the disk, that's going to take a long time in CPU time. And so you say, okay, let me process this other request instead while I'm waiting for my read to go through. Right, and so the way that this works is that it has a lot of parallelism. In this particular model, you're gonna have blocking system calls. So like whenever you do something that requires an operating system to elevate privileges, you're gonna have to wait for that to finish, and it's usually gonna be kind of slow while you're waiting. However, you can switch threads and work on something else in order to maximize your CPU time. And you're gonna have linear threads for a single process, which allows you to take advantage of this input-output delay and use that time to instead process other requests. The second way is single threading. So in this model is not there's no parallelism. We also have blocking system calls, which means that we're gonna have to wait for the operating system to finish our requests. And then we're basically just gonna process our requests, first in, first out, like a queue. And then the third but most interesting way, in my opinion, is a finite state machine. And so here we're basically just gonna have a lot of threads. However, we're gonna have non-blocking system calls, right? So that means, like, let's say I try to read a file. I'm just gonna do that asynchronously. I'm just gonna tell the operating system, hey, give me this file data, and then I'm gonna work on something else. And then the operating system is gonna tell me when it's done, and I'm gonna have to process that instead. However, this way is a lot more complicated to implement. It's gonna make your code a lot more complicated as well. And you can only use a single thread for this, since like multi-threading is typically not good with non-blocking system calls. It's just gonna increase your synchronization errors. And so yeah, so our servers, in order to access server, here are some common ports we're gonna use. HTTPS is port 443. So if you ever access the website, you're either gonna use 443 or port 80 at some point along your network chain. And then port 22 is SSH. So if you ever use like the Linux SRV for CS31, they have the dev environment in there to test your code. That's using SSH. And then so how exactly do we interrupt our server from our client once we connect to them? Well, typically the way that we have to do this is to have a separate endpoint where we're basically sending them messages saying, yes, we want to, interrupt the server to do something else, or we can just like abandon our connection and just kind of wait for the connection to time out. Since for the client, it's that going to be no impact for us, but the server is going to have pretty much a dead connection for a pretty long time afterwards. And there's also two different ways to handle server connections. We have a permanent state. This is stateful, and a session state as well. This can be in both stateful and stateless. And so our permanent state is basically just like the data you put in a database. And a session state is like if you ever log into a website and then after a while you try to access the website again and you have to log back in. But that's basically the session state. You're storing your login details so that so that you don't have to relog back in. And so yeah, let's try to classify these features under whether they're going to be stateful or stateless. So login, what do you guys think? Let me flip a coin, just like shout it out. Session. Yes, you're gonna need a session state for that. Yeah, but like for stateful or stateless, which one do you think it is? For login?
Session state. All right.
Like, it's like one of the big two ones.
I'm not really sure that.
Okay. I think you're rumbling there. What do you think? Stateful. Yeah, if you're gonna need technically you can do this statelessly because so it depends on the implementation for this one. So you can do it like statelessly if you basically log in, you send them like a cookie or something, and so each request you basically have your server checking that cookie. But like I mean, it is typically stateful in that case, right? Dark theme, yeah. If you like click the button and you change what to dark theme, what's it gonna be? Bro, do the same.
Stateless.
Yes, it's gonna be stateless. The server does not need to know whether you're rendering your like VS code into dark mode or like auto citing text. But say it. You already said it, bro.
Okay, I think I got it. Stateless.
Yes, okay. And then e-commerce. Anyone? Stateful or stateless?
Stateful.
Yes. If you want to buy something, Daddy Bezos is gonna have to inform what you bought. So yeah. All right.
Well, yeah, then actually, any questions on that? Okay. Yeah, just talk about code migration. Okay, so what might be an occasion when we would want to move code from one computer to another? I have a couple common examples up here. So for example, if you like you're throwing away a server, right? So or something, right? You probably want to move the code to the new server so you can continue operating a service. If you're collaborating with others, right? Well, more than likely, some of you guys have used GitHub before or some other kind of Git just generally service. So yeah, you probably want to be able to have a way to directly share code and have control and all that. And then obviously with distributed systems, if you want to kind of run things in parallel, maybe you have like a master node that has the code on it, and you have a bunch of worker nodes. But you have to find a way to actually kind of like, maybe you want to add a new worker node to kind of scale up, right? You have to find a way to share the code with that node such that it can actually run it properly. So with that, there are some concerns that actually kind of come up as well, as probably is expected, right? So one of the key things is making sure that the code that you're migrating is homogeneous. So what we might see is that maybe the other node that we want to kind of migrate our code to is running a different operating system, or maybe it only runs particular programming languages or something like that, right? So we have to find a way to kind of account for it. Okay, so we're going to delve back to that in a second, but a quick note on some of the common tools that you'll probably see for code migration. So for code sharing, I put up a bunch of kind of products that use Git here, GitLab, GitHub, Bitbucket, basically some form of version control for code. And then you can also share not only the code, but the actual kind of virtual machine that has a specific OS associated with it for kind of more portability. So yeah, commonly you'll see Docker used for the actual kind of containerization aspect, and then Kubernetes used mainly to kind of deploy and scaling. Not really directly used for sharing, but it is kind of directly tied to running games. Okay, so yeah, talking a little bit more about how we can actually account for the differences that we'll see in our nodes, assuming we want to kind of migrate some code from one node to another. Yeah, the key thing to keep in mind is that we are really trying to make use of load balancing and parallelism. That's the whole reason why we kind of would want to migrate code from one node to another, so we can run both of them in parallel. So more than likely, the approach that we'll have to take is to either kind of containerize everything on our current node and then share it with the other node, and then start it up with the other node. And then we may end up having both of our nodes live at the same time, or we'll have to kind of turn our current one off and then turn the other one on, which kind of leads to this last bullet point here, where we have to think about whether we're going to actually have any downtime or not. So depending on the service that we're offering, this may not be acceptable, right? So we may not, for example, maybe the service needs to always be live. And if it goes down for like a minute or something, then we're going to have big trouble. So if we need to migrate our code from one node, maybe an old server to a new server, we'll have to kind of find an efficient way to do it. Most commonly, what you'll see is that we'll kind of go with that approach that I mentioned, where we'll containerize the code, move it over, keep our old server running, and then turn on our new server and find a way to kind of on the routing side, route to the new server until the old server is finished handling its existing requests, and then we'll turn the old server off. Okay, so any questions on code migration? It's not super like key, I would say, but it's good for you to kind of have an overall idea of how it works, so that you can kind of move your code around as necessary. Okay, any questions on that? Okay, cool. So then, yeah, here we have the feedback form. This link is the same as the QR code. So yeah, do scan this and fill it out. And then once you get the code, show us the last page, and then you guys can more than likely get the pizza. Unless that's okay. Give me the pizza after this.
Sure.
Okay. Yep. So you scan this, fill it out, show it to us. You can get it. And then we're gonna have a product list. Yeah. No, you don't get it. You don't get it. Thank you.
Yeah. That would do. Like, wow.
Trying to figure out the last slide, too. Trying to figure out the last slide. Trying to figure out really quick. I don't know.
Yeah.